Hello, I'm Raquel Oliva,
And I'm Katelyn Lapine.
and today we'll be presenting an inventory and assessment of Banks Lake National Wildlife Refuge. Our co-authors include Dr. Adam Maluski, Sarah Asher, Dr. Todd Rasmussen of UGA, as well as John Faustini and Michelle Moorman of the U.S. Fish and Wildlife Services.
To provide some background information about the refuge, Banks Lake was created in 1985 in southern Georgia, which is about an hour away from the Florida-Georgia borderline. This area encompasses around 3,500 acres of land and is home to multiple habitat types, including cypress swamps, marshes, and open water. Its most notable feature is the Banks Lake itself, which is a shallow blackwater lake with cypress trees growing out of it, shown in the picture. And this refuge was initially created for the protection and conservation of not only these unique habitat types, but also to protect the diverse amount of animal and plant life that lives on the refuge. Because this refuge is located in the south, the climate is categorized as humid subtropical. So this means that this area will experience hot and humid summers and mild winters. The average precipitation rate is around 40 to 52 inches per year, and the daily temperature is around 60 degrees Fahrenheit. The current goals of the facility are to provide a overall healthy and safe ecosystem for the plants and animals that live on the site, and also provide a sustainable fishery for recreational use. So these goals are kept in mind while creating the WIRA, so we can help identify any threats to these goals.
And the WIRA, or a Water Resource Inventory and Assessment, is a report conducted for the U.S. Fish and Wildlife Services and specifically for their National Wildlife Refuge System. And this organizes a network of wildlife refuges across the nation. So while each wildlife refuge has significant different features, the report is structured to classify and centralize their environmental data. Some common elements throughout all the WIRAs include each National Wildlife Refuge boundary, and these are established by the U.S. Fish and Wildlife Services, the region of hydrologic influence, and this demonstrates the area influenced by water resources around each refuge. Also, the acquisition boundary of which the refuge is approved to acquire land in. So once the report is finished, a culmination of hydrologic and climatic assessment, as well as a list of threats and needs, will be used to help with the refuge's future management plans. So to start creating the WIRA, first we need to acquire the essential environmental data from various national databases. So this can include wetlands from the National Wetland Inventory or soil data from the U.S. Department of Agriculture, flow lines and water bodies from the National Hydrographic Dataset or the U.S. Geological Survey, and much more. All this data is then imported into ArcGIS products, and they are clipped to the refuge's RHI, or its acquisition boundary, or their individual refuge boundaries. And this is all organized into a geodatabase. The attribute tables of these files are then converted to user-friendly tables and organized into structured maps to help visualize the data. Finally, data retrieved from surface and groundwater stations are run through RStudio, and this helps create hydrographs and also assess water levels. Similarly, data provided by the National Oceanic and Atmospheric Administration, or NOAA, is analyzed for climate in terms of precipitation and temperature over a number of years. So here are a few examples of the maps created through ArcGIS. On the left is a map designed for water bodies as determined by the National Hydrography Datasets, or the USGS. And this is outlined and labeled against the RHI, which also encompasses the hill shade derived from topographic DEM data, along with the red outline. And this distinguishes the refuge's acquisition boundary, as well as the refuge's boundary outlined in light gray. On the right, the map includes similar elements, the RHI, the acquisition boundary. However, it has a legend for the targeted environmental feature, which are wetlands. In total, there are 25 different maps created for the report. Each map displays a distinct environmental feature, including geology, topography, and soil series.
One limitation that occurred during the creation of the WIRA was the collection of surface and groundwater data. Not only were there a limited number of stations near the acquisition boundary and the region of hydrologic influence, but these stations didn't have the most current data. So when analyzing the data, it was helpful to visualize exactly where the stations were pertaining to the refuge and the RHI, so we could weigh their importance. This map includes water-related infrastructure, such as MPDES permit facilities. This data was obtained through the EPA, or Environmental Protection Agency, and shows the locations of facilities that have permission to discharge pollutants into local water bodies. This feature is important to note because it could directly impact the refuge's ecological sustainability.
So water quantity analysis is a part of the WIRA, and this creates hydrographs shown here on the left from surface water stations. And these surface water stations are plotted on the map towards the right. Station 3 is used for analysis, and it is an upstream stream gauge. And this was chosen because it had the most observation counts and also the most recent data collection from 2020. Although it was the only stream gauge around the RHI with the best record, a distinct line disrupts the data, and so this could indicate missing data. The second part of water quantity analysis deals with groundwater levels. Out of the 7 significant groundwater level stations, only one, represented by the dot labeled 7, contained consistent measurements of groundwater levels. However, this station only encompasses data from the years 1965 to 1988.
The WIRA also includes climate analysis of the refuge. This includes creation of bar graphs, as shown on the left, from historical climatology network stations, which is mapped on the right. The HCN station, labeled with the number 1 and indicated by the symbol of a diamond, is used for the primary analysis due to the lack of consistent data from stations within the RHI. To summarize the graphs, the average monthly temperature peaks from June to August, reaching about 98 degrees Fahrenheit, and precipitation peaks in June and July with a little over 5 inches per month. So this makes for hot and humid conditions during the summer months.
The annual precipitation and temperatures are also observed between the years 2001 to 2020. On the left is a plotted graph of annual temperature with an average of 66 degrees Fahrenheit. The trend line indicates an incline of temperature after 2009. On the right is the graph of annual precipitation with an average of 51 inches. And its trend line dips during 2009, but rises soon after. So findings, although one of the first sections in the report outline the summary of the report, and this includes main types of land use, which is determined by the land use land cover map. Findings also include a summarization of water monitoring sites, all 56 of them, but it should also be noted that there are gaps and inconsistencies in data. The ecological aspect of the findings focus on migrant birds and other endangered species.
The determined threats and needs of the site were done through analysis and interpretations of the created maps and findings, as well as personal communication with staff at the refuge. The highest priority concern as of present day is the water hyacinth, which is an invasive plant species that can cause low dissolved oxygen levels at the refuge. So improving efforts to control it is essential to maintaining optimal habitat conditions. Another threat to the site is a local sod farm, which has illegally pumped water for irrigation purposes in the past. So this topic and the refuge's water rights needs to be further investigated in order to do anything. Just in general, the refuge would really benefit from an increase of staff on the site to consistently monitor the area and make sure everything is running smoothly. And finally, water level data needs to be put into a centralized location for future reference and use. Okay. So in conclusion, as populations and global temperatures continue to rise, the need for reliable resources pertaining to water quality and quantity is essential. And with a standardized method of assessment for the National Wildlife Refuge System, this information is accessible. So the WIRA that was constructed for Banks Lake should hopefully assist in the mitigation of both current and future water resource problems and just lead to an overall more stable and healthy ecosystem. Thank you.
Thank you.